This
Today,
conference will now be
our
recorded.
these things. This is the agenda of our project one. So our agenda is about training, right? The course of training, how it is. That we'll discuss. So I'll discuss in the beginning only because so many few will be having some other work to carry on. So I'll discuss about course details. So how the course is carried on. So next I'll discuss about right PD queries. If you have anything, right, you can ask me or PD questions. Anything. Next I'll discuss about PD questions means relating to the course. Next I'll discuss about what is physical design. Means why we do physical design. What we do in physical design. So next is steps in physical design and our course content. What is covered in course, right? So these are the agenda for today's discussion. So first coming to the course details, right? Just 1 minute. Okay. So now course details, right? See this course, whatever we are carrying for physical design is classified into two things. One is PD basics. Second one is PD advance. So in PD there is entire course is split into two things. One is PD basics and one is PD advance. So the course duration is 5 to 6 months. Within this, not more than this, within 5 to 6 months. It may happen for 5.5 months or 5 to 6 months. So here basics we have two things again, PD basics and PD advance. See in PD basics only the basics required for this physical design course is discussed. It is not that everyone should attend this. If you want, you can attend the PD basics, or if you know the basics, then you can directly go to for what advance. There will be some expertise like persons who are already experienced, like faculties, and they know the concepts of basics, right? They can skip this and they can go for advance. And if you feel that if you want the basic course, then you can go for basics. See, out of this 5 to 6 months, right? So totally 2 months is for basics we take, and remaining 3 months is for advance. So this may slightly vary. This is instead of 2 months, it can become 2.5, or 3 months, it can become what? 3.5, or it can close with 2 months only. So it depends upon the holidays, right? Like if you get Dasara, Deepavali, right? Students will go, and so the course may slightly get extended. So apart from that, it will, if there is nothing like that, and it will complete within the 5 months. So what is covered in PD basics, right? See, please ask all your questions, whatever you have, everything. Okay, your voice is not audible. Yes, online my voice is not audible. Yes, online students, whether voice is audible,
It's
Audible,
audible,
sir.
sir.
that's clear. Voice is clear.
Yes, sir.
Yes, yes, sir.
Yes, sir. Yes.
So you have PD basics for 2 months and PD advanced. So the person who is telling voice is not audible, right? Please rejoin the meeting, like exit and join again. So probably he'll not be even listening to this. So better we will think again. Will not send this to everyone. Okay. So you have PD basics for 2 months and PD advanced for 3 months. And in PD basics, what is covered? Right? We are going to cover digital, digital basics. See, digital is not effectively used in physical design. Like at least you should be knowing what is mux, what is flip flop, what is latch, what's the difference between flip flop and latch, right? What is that basics you should be knowing. And even though the questions are the digital is not used in physical design, but for the freshers, right? The questions on digital may be asked in interviews. So in that point of view, also you should look into the digital course. But apart from that, in physical design, digital is not much used. So we are not going to design any mux or decoders or any flip flops or counters. But only thing we want is at least you should be knowing what is mux. You should be knowing at least what is flip flop, what is a latch. That basics knowledge you should be having. So we will first cover with digital. So after digital, right, we cover Unix basics. Unix is a Linux operating system command. So you have Windows, right? Here, this is a Windows. How do you create a folder? Right click, new folder, right? This is a graphical user interface. But instead of using graphical user interface, you can create the folder by using commands also in Unix. If you want to copy the file, you can copy through command. See, command is very easy instead of using GUI, because there copying files, creating folders in physical design doesn't happen with only one folder or one file. Plenty of files and plenty of folders are involved. Thousands of files. And see, if I ask you to create 100 files, it's very difficult by using graphical user interface, but we can easily create by using commands. Only one command can create 100 files, right? So for that reason, we will understand what are the commands for this. Unix means it is Linux operating system. See, we are not going to use Windows. We are going to use Linux operating system. Even company is going to use Linux operating system. So what are the commands to interface with Linux operating system? How to create a folder? How to copy the file? How to create a file? Right? All those things, all the commands will be discussed here. All the basics. This is very, very essential for physical design. Not only for physical design, any VLSI course, this is very essential. As a fresher, when you go to industry, you cannot tell that I don't know this command. You should be knowing this commands. Right? So this course is done. This will almost take 4 to 5 classes to complete. Right? Next, we will cover GVM basics. See, GVM is a text editor. What is a text editor I'm using here? This is what text editor, what I'm using here. Typing, you have Windows, Excel, Windows, Word, Microsoft Word. This is a Microsoft Notepad, I think, right? Like, so similarly you have a text editor called as what? GVim. Nothing you have missed, right? I was just telling what are the course content, how the course details is. So we will do GVim basics, how to use a text editor. See how to save this file. Control S, right? There are some shortcuts even to use this GVim text editor that is used in Linux operating system. So what are the shortcuts to use this GVim text editor? So how to enable, see this, I am not seeing any line numbers here. But if I have GVim, right, I can see the line numbers also. I have GVim in this laptop. Yes, GVim is there. Even this file, whatever I'm opening, I can open with GVim only. Open with Vim editor. Whatever you're seeing now is a GVim. If I want to get the line numbers, I should press escape colon set new. I'm getting what? Line numbers at the left. I want to find any word in this. What you will do generally in the text document, what you will do, Control F and find where Unix is present. Right? It's pointing Unix. So how to find in Vim? Slash Unix. It is showing, right, yellow color showing where what is present. So like this, right, you have some shortcuts to save the file. You should press escape colon w exclamatory mark, right? That is going to save the file. So you have some shortcuts how to use this GVM text editor. This is not a notepad. What is this? GVM. So how to use this GVM? So see, I want to replace this, right? I want to replace this Unix by digital. Then how to replace this? Escape colon percentage yes. So what, wherever you have Unix, right, replace that by Linux. So Unix has been replaced by what? So in the entire page it will replace. How to do undo? U means undo. So like that you have some shortcuts to use this GVim. So that basics is done here in the GVM basics. This will happen for only for 2 days. It's not a very big course, just a shortcuts how to use this. So this you will learn only if you use in day-to-day life. If you daily, if you use this, right? I am working in a company, I am using daily. I am expert in using that. So when you use daily, you will feel very easy to use that. So next is we will do TCL basics. TCL stands for Tool Command Language. See, tool command language means, see, whatever we work in physical design, we work with the tool. That tool is going to understand only this language. What is the language? Tool command language. Like your C, C++, right, is also one of the language. It is not very complicated like that. It's very easy language. If I want to interact with the tool, if I want to give any input to the tool, I can give only with what language? TCL. So we will do all TCL basics. What are the syntax for while loop, syntax for if loop, syntax for each loop, how to do the file operations, right? How to, what is a regular expression? So everything, all the basics, list, arrays, all the basics is done here in TCL basics. So next, one more basics we do, that is CMOS basics. So this is very, very important. CMOS is very, very important for physical design. CMOS means, I think everyone is knowing what is NMOS, what is PMOS, what is CMOS, right? Complementary metal oxide semiconductor is combination of NMOS and PMOS. Then what is a structures like AND gate, how to implement by using CMOS, OR gate, how to implement by using CMOS, and what is layout, right? Physical design mainly deals with layout. What is layout? How to draw the layout of those things. So all those things are covered in CMOS and fabrication process. If I want to fabricate the CMOS, what is the process? I have P substrate on top of that. We'll do oxidation. We'll do masking. After that, we'll create envelope. After that, we create source and drain. Right? The CMOS process. What are the process steps used in fabricating the CMOS? So all these things are covered in PD basics. So this will take for 2 months. So PD basics will happen on Monday to Saturday for 3 hours daily. So this will happen on Monday to Saturday, and it happens for 3 hours daily. And generally, it will be from 9:30 to 12:30 or from 9 to 12. See, basics is not there for weekend, as of my knowledge, but you can talk with admin, right? You can talk with admin to discuss about weekend course for basics. Just I'll confirm with admin. Wait, like I'll just give. Yes, sir, for weekend courses, right? Admin told to contact him, so he will give the flexibility of attending weekend. He is telling to contact him, right? But general course happens from Monday to Saturday, and all these basics, right? You will get the live recording videos. See, admin is a Manohar, right? If you don't have a number, right, you can type in your WhatsApp if you have. They will give you the number of admin. So you will get live recorded videos. Right? So live recorded videos means if the class is done today, unfortunately you have missed the class. So then that video you will get after 4 hours, because we need a time to upload it, because it's of in GBs. Right? We need a time to upload. After 4 hours, you will get this live recorded video. So you can, if you have missed for some reasons, then you can get these videos. So you will get live recorded videos for all the sessions immediately when the course completes. Not course, a session completes. After 4 hours, you will get the video. Every day video you will get, and that video is available for next 15 days. It's not accessible for lifetime or course duration. It's available for what, next 15 days. After 15 days, that video will be replaced by new videos, right? So this recorded video is given only with the thing intention that if you miss the class, you can cope up by seeing that, or you can watch those videos and you can come back to the next classes with that preparation, right? That is the intention of this live recorded videos. So next we have PD advanced course. So PD advanced course, again we can classify into two things. One is PD theory and PD lab. See, PD theory is going to happen for weekends, that is Saturday and Sunday for everyone, right? It's going to happen only on Saturday and Sunday, because theory is just watching what is the theory part, right? But everyone has to work on the project. So working on project is difficult. So lab is going to happen on from Monday to Thursday, and Friday is the off. See, as this is happening on Saturday and Sunday, even weekend candidates can also attend. Weekend means the candidates who are not able to attend on Monday to Thursday. Even PD lab happens on Saturday and Sunday also. Saturday and Sunday. This Saturday and Sunday session is only for the candidates who can't attend on weekdays. See, there are few candidates who cannot attend on any mode, right? If the see what happening is for weekend currently, this weekends, right, Saturday and Sunday, no one is coming. Everyone is attending online. So the trainer is also attending online from home. The trainer is doing that. If the any candidate is coming, the trainer will also come, because they are not staying very far away, they are nearby only. They will come and they will take the class. So if no one is coming, we will take offline online, but if any candidates are coming, they will come online. right? That is there, but they should come regularly. That's it. That is what we expect. So this PD lab, again, it is two things. One is weekdays. Monday to Friday is what? Weekdays. Saturday and Sunday is what? Weekend. Both are different things. Right? Don't attend both. Any one you can attend. If you are available on weekdays, attend from what? Monday to Thursday. If you are not available on weekdays, attend on what? Saturday and Sunday. So this happens for 3 months, right? And here in PD Advance, see here also you are going to use your laptop. All these things are digital only, is not done by using, it is not a, it is only a theoretical concept, digital concepts are. But Linux, GVM, TCL, you have to bring the laptops because tool will be installed and all these are hands-on. It is not theory classes. All are hands-on. Hands-on means you will also parallelly work along with the trainer. GVM Unix, you will also execute the command. Trainer first he will type the command. By seeing that you will execute the command. If you get any error, trainer will help you, or he'll go to the next command. So all the three things are hands-on. All the three things. So trainer will guide you how to install the tools relating to this, and you can continue with that. So you should bring your laptop even for PD basics. Even for PD advanced, you should bring your laptop, and we will provide the tool that is ICC 2. This is for physical design. So we will ask you to install this tool, ICC 2, and this tool is accessible 24/7. It is not that you should access only during the class hours. You can access 24/7. Even home you can access. See, because everything you cannot do in the classroom, right? Your trainer will help you to fix 10 violations. Remaining 10 you have to fix in home. That is how you are going to learn, right? So you can access anytime 24/7. And here also, right? The same thing. Live recorded videos are given. Here also, both for theory and lab, the live record videos are given. For PD advance also, they will give you the in-skill password and username. If you log into that, the videos will be uploaded as the session is completed. When the session completes, the videos are uploaded automatically, right? And this theory happens on Saturday and Sunday in the morning, like 9:30 to 12:30, and weekday students they can go to home, and weekend students they can attend the lab from 2 to 5, 2 to 2 to 5. Yes, so this will be generally between 9:30 to 12:30, right? So Monday to Thursday, right, you have lab. That will be also generally in the morning or sometimes in the afternoon, depends upon the strength, right? We cannot do, for example, in this batch if we have 60 students, we cannot do both the batches on same time. 60 students we cannot do parallelly because we should also get the license for ICC2. So we'll split into two batches. At a time there will be one batch in the morning, one batch will be in the afternoon. But for weekend candidates, after the theory, weekdays will they can go to home, but weekend they are going to attend the lab from 2 to 5 p.m. And if it can be even modified according to the convenience of the candidates. For example, some candidates tell that Saturday we cannot attend at 2 o'clock, we can attend only at 4 o'clock, then we can reschedule it because we have only less candidates in weekend. According to the requirement of candidates, this timing can be rescheduled. So classes happens every day 3 hours, and here also live record videos are given, and tool is given 24/7, and our team is going to tell how to install the tool. Laptop, you can use any laptop you want, like it is, there is no restriction on only should have this version, right? Even You can have any processor, anything, because you are not going to work on your laptop. From your laptop, you will connect VLSIGuru server. You are going to work in our server. Whatever you're doing, it is saved in our server, right? So you can use any laptop you have. And the tool access will be removed from you once this PD advanced course is completed after 15 days, right? Like PD advanced course complete after 6 months, then after completion, I tell the trainer tells, okay, this day I completed the course. Next 15 days tool is given to you for practice. 15 to 20 days. On request, they may extend to 1 month also. If you ask them, please extend me to 1 month, they will extend to 1 month also. So on request they will extend, and after that they will remove the tool access. From online, you cannot do tool access. It's only from online. Because what happens is if we give the tool access, right, they are selling the tools. Tool is very costly. It is not so easy. This license is very costly. What they are doing is the candidates are selling the tools. But once the tool access is removed, you can even access the tools when you come to VLSIGuru Institute. You can sit in VLSIGuru Institute from morning 9 to evening 8 o'clock, night 8 o'clock. You can work the tool for next 1 year. There is no any time till you get the job, you can work. You will only not work. After getting the job, there you have pressure, work pressure, and you will not come here. That's it. But till you get the job, you can work. After till course completion and next 15 days, tool you can use from anywhere. There is no restriction in that. But after that duration, tool you cannot use the tool from online. But you can use the tool if you come to institute. So we are only removing the VPN access. VPN means you can use the server from anywhere in the world. That access we remove. But your ID and your password, everything, your session will be as it is. You can come to institute, you can come and connect to the VLSIGuru. That ports are there, right? LAN cable ports. You can connect to that and you can use our servers and you can use till you get the job. There is no restriction, right? So this is about the tool access. And the same duration for weekend and weekdays batch, because see weekend is, see only the fees cost. Whatever I'm telling is only with the fees cost. Nothing additional charge will be done. If at all, see I repeat once again, tool access is given to the students till next 15 days after the course completion. On request, it may extended like 1 month. It's on request, like I have fever, I have some problem, right? It can be extended. But after that duration, if you want to access, you should access from the institute only. You should come to the institute, bring your laptop, sit in the room wherever it's free, and use till night, right? You can do that. But if you want to use again from the offline, then you should pay and you should use the tool. But using in the institute, there is no charge. So we are not going to charge anything if you coming and if you are using the institute, right? We don't have any problem in that. And same duration is for offline and online. So you may think that offline lab is done for 4 days, but this is done only for 2 days. How the syllabus can be covered? See, syllabus can be covered because offline this Monday to Thursday, right? We have more candidates like 60 or 70 to handle. So solving the doubt for all 60 to 70 and covering the syllabus will be equivalent to covering 5 to 6 candidates in the weekend. So weekend we'll be having only 5 to 6 candidates. We can easily solve the doubts and we can easily cover the syllabus. Uh, so both will be covered at the same. See, there is no deviation in the concept. Both will be covered with same concept. But only thing is Saturday and Sunday weekend candidates will be only less for us. It will be like 5 to 10, not within 10, not more than 10. But Monday to Thursday, right, we will be having a candidates more than 60. So last batch we are having more than 90. I mean, in previous batch we are having more than 100, right? So handling all those students is very difficult. So we have Monday to Thursday. Sometimes we do on Friday also. If we have more doubts or more issues coming out, we do on Friday also. But Saturday and Sunday is peaceful for us because only less candidates. That lab can be done very easily. because at the beginning it will be difficult because everyone are using that tool with new things, like we have to clear the doubts for everyone, so it happens at same thing. See, you can appear, see, Monday to Thursday lab, you can also attend on Saturday to Sunday, but same topic is covered, it's of no use, right? You will get confused sometimes. Weekdays mentor will be different and weekend mentor will be different, right? So you will get confused, don't do that. You follow any one thing. See, it is like, if you have more candidates, we will split the batches and we will give importance to everyone if you have doubts. So anyhow, weekdays the mentor is available offline here. If you have any doubts, you can come to offline and you can clarify also. If you are attending online also, it's okay for us. And mode of conduction is both offline and online. How it is happening now, I am handling the sessions both offline and online both, right? Few students are attending online and few are attending offline. In the same way the session is handled. See, after 15 days of completion of PD advanced course, the for the tool access, you can request to the admin with the valid reasons why you want tool access, right? Admin can extend for other next 15 days. So it can be extended till 1 month, max to max. After that duration also, right? If you want to get the tool, then you have to pay for the tool. So max to max, it can be extended till 1 month. So that is done always. Yes, Srusti, I made it clear. If you are not available for PD basics, please contact the admin. Alright. Admin will help you how to attend PD basics online. Sorry, that is weekend. Attend PD basics weekend, admin will see. Please. So you contact the admin. Right? There is a two options. I will tell you what admin is going to tell. There are two options. If we have enough students, like if we have more students attending PD basics on weekends, we will conduct a separate class. If only one or two candidates are there, what we do is we give the recorded videos. You watch the recorded videos for all these things. If you have any doubts, right, we are going to clarify those doubts by using a mentor. So out of these two options, one options admin may suggest you. So please contact the admin. Right, he will tell you what to be done. Yeah, apart from live recorded videos, you will also get other recorded videos, which is pre-recorded. Right, that is available till the course duration. Live record video is available for next 15 days. Today's video is available for what, next 15 days. Tomorrow's videos is available for next 15 days. But you also get pre-recorded videos. It is done somewhere before. That videos is available for entire course duration that you can watch. Okay, so this is what about the first thing what I want to discuss, right? Course details. And I think I am very clear with the course structure, what is happening in the course. So any other things you want me to know, you can discuss me. I will give just other 5 minutes to discuss your doubts. Okay, about the placements, right? I'll come to this time only, right? See, there are again placements. When I come into the placements, there are two types of companies. One is what? Service based. One is product based. See, product based companies are like your Qualcomm, MediaTek, Nvidia, Intel, right? All these are what? Product based. And service based companies are nothing but, they see, product based companies, they will not hire the candidates directly without any experience. They always expect the experienced candidates, because product based companies, they don't want to invest time in training, and uh, see, they will hire the freshers also, but not bulk in number. They hire only very small. So generally they focus on internships on from top universities like IIT, NIT, and something, right. They hire from there and they allow the students to go the internship. Based on the internship, they will hire the candidates. That is what these product based companies will do. And if they want to hire any candidates from the outside market, right, they will hire only the experienced candidates. So these product based companies, at least with 3 or 4 plus years experience. But service based companies are not like that. They will hire the freshers, even they'll hire the experienced candidates, and they will train. And these service based companies will work on the projects of what? Product based companies. They will send you to work on the projects of product based companies. So we have tie up with both service based companies and product based companies. So if you are very good, your basics is very strong, and if you're very good in working your TCL tool command language, you can work very good. Then you can get into what? Product based companies. Recently also I have seen in my thing, right. I have seen in the placement group. Mm, students are getting placed in Nvidia, MediaTek. Right? These are the product based companies, right. Even recently they have got placed, and many students are got placed in. So I'm not getting that page now. Yes, here, right. Yes. So many students are getting placed in service based companies. So physical design. So there is no difference in attending online or offline, right? Everything remains same. There is no change in even the support. Also, placement of support remains same. So to get the placement, we have some strategies to do. See, we during your PD basics and during your PD advance, right? We will give regular test. We will give regular mock interviews. So you have to at least score very good marks in both to get the placements from VLSI Guru. See, finally we do the mock interview after PD advance. If your previous test marks is very good and your final interview is very good, then only VLSI Guru will forward for the placements. Right? Then only we put you in the job support group. In that we are going to post all the uh, requirements what we are getting from the companies. They'll directly mail us, and we will post in that groups. We'll collect your resumes and we'll forward them. See, why we do this filtering is, for example, if one candidate is going to the company today, and if he's answering very good, the company will come back to us. Right? If the person is not answering very good, he is not at all prepared, and if we are forwarding him to the company, and if the company is upset because of his performance, they will not come back us, and that is going to affect the placements of other candidates. They not if they're not coming back to us, that is going to affect placements of other candidates. So for that reason, what we have is we have filtering mechanism. Filtering means it's like if you are prepared well, then only we are going to forward to the placement. So we will conduct them. See, mock interview is not very difficult. We are not going to ask very difficult mock interviews. We are not going to do that. We are going to ask at least ASIC design flow, what are the basics you have learned, whether you have learned that properly or not. We are going to test that. If you are answering that and if your test marks is okay, good, at least 60% or 70% of marks you have scored, then obviously we are going to forward you for the placements. See, shifting to weekdays, it's your wish. Shifting to online, shifting to offline, it's your wish. You can, if you register for the course, you can do anything. But see, shifting to online or shifting to offline is okay. You can attend offline whenever you want. If you want to attend online whenever you want, that is your wish. But shifting the batches, weekend to weekdays, weekdays to weekends, we don't have any problem. Institute is not having any problem with that, right? But you will get confused because he may be taking some other topic, she may be taking some other topic. If the same mentor is taking weekdays and weekend, then it is okay. If there are different mentors, then it becomes a problem. If same mentor is taking weekdays course and weekend course, then you can shift. Shifting is your totally your decision. In institute is not having any problem in shifting the batches. If you are not available for this batch, you can also join for next batch with the same fees. First 10 days you attended, and if you are not able to continue, and if you want to join the next batch, you can tell to the admin that I'm going to discontinue and I'm going to join the next batch. You can do that with the same fees. We are not going to charge anything extra, right? That is also you can do. You can shift from weekdays to weekend or weekends to weekdays, only if you are okay for that. But don't get confused with the topics covered, right? Currently I'll give you an example. Currently I'll the weekdays whatever the mentor is taking, she is doing the concept of placement. For weekdays she is two classes behind. For weekdays she is forward. For weekend she is two classes behind, right? But for weekdays she is already forward. She has went to two classes forward. But for the weekend she is two classes backward. So same mentor it is, right? So if you shift from here to there, then you may get confused or you may lose some data, right? That is what the problem is. But shifting, if you're okay and if your mentor is taking the same concept, you can shift. So institute is not having any problem with that. And I tell you one thing, attending weekend is good, right? It is my personal experience, because weekend is having only less candidates. You will get sufficient time. If your luck is good, only two candidates or three candidates is there, then a mentor is going to give focus only for these two to three candidates. So you can learn, you can clarify your doubts better, right? Weekend is better suggestion, what I say, to attend the labs. No, that is what I have told the timings, right? This is the timings. This can be rescheduled if you want. Apart from that, if you're not available, right, you should depend upon the live recorded videos. Timing is fixed. So this timing, right? This may be Monday to Thursday. It is 9:30 to 12:30, or depending upon the size of the batch, it can be again one more batch, maybe from 2 to 5. Because if we have more admissions, we cannot do all the students at a time, right? We should split the batch: morning one batch, afternoon one batch. So this, if you split, one batch will be in the morning PD lab, other batch will be in the afternoon. Because lab we cannot do 70 students at a time. Theory we can do. It's theory is almost one side communication, but lab is not like that. Lab mentor has to do. Again, you should do. If you have any doubts, your mentor has to clarify. That is what. So if we have more than some, if we have more than 30 candidates, we will split it into two batches. One batch max to max 30 candidates, 30 to 35, not more than that. So placements, service-based companies, product-based companies are already, if they have requirement, they directly contact us, and we are going to put you in the job support group if you are clearing your mock interviews. And if any requirement, we will post there. We'll collect your resumes. Requirement happens based on your marks also, right? Because the company may ask, throughout there should be 60%, throughout there should be a 70%, right? Like that. So if your criteria is meeting, then we'll collect your resumes. We will forward to the company. Company will conduct the interview and they will hire you. This is the process what we follow. Okay, next is, right, we will go with the technical content, like what is physical design, why, what we do in physical design. and what is our course content in physical design, right? See, VLSI means, what is VLSI? Very large scale integrated circuits. So here we are integrated circuit means what? IC. IT means IC means integrated circuit. So entire requirement of your design is present in only one chip, complete chip. For example, in mobile phone, I have complete chip for what? Entire operation. I have transmitter, receiver, audio, video decoder, encoder. Everything is present in what? One chip, complete chip. So can you tell me the size of the chip? It will be in centimeters, right? If you see the outside chip, it will be in what? Centimeters. That including the package. I think you have seen the chip, right? Everyone has seen the chip, I think. This is a chip. So this will be in centimeters, correct? But inside this, how many cells will be there? Crores. Millions is gone, right? Now we are working in crores. That crores only we see 1 million means 10 lakhs. We call it as 20 million. 20 million means how many? It is almost 2 crores. 10 million means 1 crore. So we 20 million or 30 million cells are present in one IC. The current design, whatever we working, it is having 30 million cells. Means what? Totally almost 3 crores of cells present in one IC, right? So this IC, if I talk about this IC, right, we have two things again: IC fabrication, IC design. I have two things again. One is IC fabrication, one is IC design. Then what is the meaning of this IC fabrication, IC design? So IC fabrication means the place where the IC gets fabricated, right? So where is IC gets fabricated? What is that place called as? Foundry, right? Foundry is a place this IC gets fabricated, and this foundry, India doesn't have any sophisticated foundries till now. See, we have foundries for research purpose, and we have foundries from ISROs, right? But these foundries are only for research purpose, not for mass production. Mass production means per day minimum 10 lakhs ICs should come out. The foundry should be capable of producing minimum 10 lakhs ICs per day. That type of mass production foundries we don't have in India till now. So our government is planning to set up a foundry, but I don't know how much it is uh, when they are going to establish that. So foundry is a place where IC gets fabricated. That place is called as what? Foundry. And this foundry should be, right? This foundry should be 100 times cleaner and neater than your ICU watts or operation theater, because a small dust powder or small chalk powder can cover thousands of transistors, because size of transistor is in what? Nanometer. So we are working in a technology called as 3 to 4 nanometer technology. Currently we are working, I am working in the 33 nanometer technology. 3 nanometer means you know this one, right? You know what is NMOS? Everyone know what is NMOS? So in NMOS you have source and drain. So the distance between source and drain is 3 nanometer. That is called as technology. So currently we are working in a technology called as 3 nanometer. That is what the least technology what I have seen till now. But even the research is going on with 1 nanometer, 2 nanometer also. But least technology what we are working is what? 3 nanometer. So technology means what? Distance between source and drain of a MOSFET. Right? That is called as technology. So foundry is going to fabricate an IC, and what is the size of transistor? It is in what? Nanometer. If a small chalk powder is there, it is going to cover thousands of transistors. It's not so easy. So getting fabricated an IC in the market, right, requires huge investment. It's not so easy to get fabricated the IC. Getting fabrication of IC, it's not so easy. If a company is coming up with an IC, it has to invest almost 500 crores to come up with an IC. Salary for engineers, everything, right? They have to invest almost 500 crores. But an IC is coming out in the market, its cost will be not more than 2000 rupees. It will be less than 2000. Your phone cost is 20,000, it's including everything, packaging, everything, battery, everything. But IC cost will be just 2000 rupees. Then how much IC they have to sell to meet this 500 crores? So IC should never fail in the market, right? If one IC is coming out and they are using in the mobile phone, and if the mobile phone is not working properly, then that company will lose the market. That 500 crores is gone. So company are very much particular that IC should never fail in the market. IC should work better in the market in terms of power, speed, and functionality, right? It should work very good. If any of this issue is, if all the three, right, power, speed, and functionality, if any one issue is coming, they are going to lose the market. If market is lost, they are going to suffer a loss of minimum 500 crores, right? So this is what the thing is. See, the MediaTek has lost the market in mobile phones, right? Qualcomm and MediaTek were the rivalries for mobile phones. Whatever mobile phone we are using now, it is almost having the processor or IC of Qualcomm Snapdragon. But even one of the core competitor was MediaTek. So there was some issue. They lost the market for this mobile phone. They lost the market. But they are also, MediaTek is having some. They are doing audio video encoders, chips, and all. They are doing. They are very good in that. So like that. But Qualcomm is very good in fabricating ICs for mobile phones. They are excellent in that. Intel is very good in this PC, right? PC, this whatever you have servers, networking chips, right? They are very good. But your AMD is very good in again PC networking chips like that. So each company they are good in their own domain, right? So now there is one more position called as IC designer. So IC design is nothing but we are going to design an IC, right? Here design engineers, see who are going to work in foundry. The persons who are working in foundry are not electronics engineers, they are mostly a chemical engineers, because the fabrication is chemical driven process and they have to work in very small size, like electron microscope they have to use. If they want to see one transistor, right, they have to use what? Electron microscope, because it's a very small size, we cannot see through our eyes also, because it in what size? Nanometer. In the scale you have smallest unit, right, that is in millimeter, this is in nanometer. So design engineers is going to work, they are going to design an IC, right? Design engineers design IC. So to design an IC, what we do, where we design, where we're going to design an IC, we design an IC by using a software tools that is called as EDA tools. What is full form of EDA? Electronic Design Automation Tools. So we have many tools in their own domain. For FPGA design, which EDA tool you have used? Xilinx, right? Most of them have used Xilinx, Vivado. So you have used that for FPGA design. Similarly, for this IC design, we are going to use a tool called as, so for each stage we use different tools, but major companies who are going to produce these tools are Cadence and Synopsys. I am telling for this IC design, right? Cadence or Synopsys. These are two major EDA vendors. Those who are going to produce these tools. So we are going to design the tool we are going to design an IC by using what? EDA tools that is going to work in software. So we are going to design IC by using our laptops only, right? But after designing an IC, the IC is going to fabricate where? In Foundry. Then what these design engineers will give to Foundry to fabricate? There should be some handshaking, right? Like they should give something, and based on that only the fabrication Foundry will do the fabrication. What the design engineers will give to the Foundry to fabricate? Yes, good, right? They are going to give what? GDS tool, GDS file, right? Just give me 1 second. Yes. So here, this IC design team is going to give the fabrication team a file called as what? GDS to file. This GDS2 file is given to Foundry. So based on this, your Foundry is going to fabricate the IC for you. So then, what is the content of this GDS2 file? See, we engineers work, we design the ICs by using what? EDA tools. After designing IC, we give what? GDS file to what? Foundries. And Foundry is going to design IC based on what? GDS file. So Foundry is not going to do anything. They are going to program their tools by using what? This GDS file. According to this GDS file, they have their automation tools. The automation tools is going to fabricate the ICs. But this GDS file contains what? What is GDS file contains? Okay, what is the GDS full form? Graphical data stream information interchange. Full form of GDS is graphical data stream information interchange. Then what is the content of this GDS file? Yes. What is the content of GDS file? Layout, right? Layout of cells and its connections. Then what is layout? That is what you're going to learn in what? CMOS. See, you know layout of at least what is layout of your this one. At least you know what is the layout of CMOS inverter. I'm not asking CMOS AND gate, right? I'm just asking layout of CMOS. So how many of you have undergone the CMOS course in your UG classes? How many were having this course? You know this is a CMOS inverter, right? CMOS inverter has what? PMOS and NMOS. This is your PMOS. This is V in. This is V out. What is this? VDD and VSS. This bottom is your NMOS. Three-dimensional structure, right? This is my P substrate. In the P substrate, I cannot create PMOS. To create PMOS, again I have to create what? NWell. This is NWell, right? This is NWell. What is this? P substrate. In the NWell, I'll create what? PMOS. PMOS source, PMOS drain. In the P substrate, I'm going to create what? NMOS source, NMOS drain. And on top of this, I have silicon dioxide, right? So we have silicon dioxide, that is a dielectric. On top of this, you have what? Gate, that is a polysilicon. So this is a gate of your N. This is a N plus region, highly doped N plus region. This highly doped P plus region. This is gate of your PMOS. This is drain, source or drain, anything can be used here. This source of your NMOS. This is drain of your NMOS. This is source of your PMOS. This is drain of your PMOS. So this is how it looks, right? Then how to draw the layout for this? This is not the layout, right? What is layout? Top view. In the top, what you're seeing that, right? That is called as what? Layout. So how to draw the layout for this? So for drawing the layout, you have a P substrate. You assume this is a P substrate. Totally, this is what? P substrate. In the P substrate, I have to draw what? N well. And I will give VDD and VSS connection. This is VDD. What is this? VSS. This both are metal layers. VDD and VSS is what? Metal layer. This is VDD. This is VSS. So this purple color is my N well and the white color is my P substrate. So inside this purple color, I have to create what? PMOS. PMOS source and drain. In between, I have what? Gate. See in top, from top of from top I see I'll see what? Only source. I'll see what? Drain. In between, I'll see what? Gate. That is what I'll see from the top. Right. So that is what I am going to draw here. So I am going to see like this. This is gate, and left side is what? Source and drain. This is P plus source. This is what? Drain. In middle, whatever you have, it's called as what? Gate. Similarly, we have what? Even NMOS also. Okay, this is a source. This is source, and this is drain. So top is what? NMOS. This bottom is what? PMOS. So this is a diffusion, right? Pink. What is pink color? Diffusion. Red color is what? Gate. It's a polysilicon. So if you see the structure here, this gate and this gate is what? Shorted. See that we will discuss in the CMOS basics. For that reason only, right? You should attend the CMOS basics, right? So we cannot discuss all the PMOS, NMOS in the demo classes. So for that reason only, if you don't know what is CMOS, PMOS or CMOS, NMOS, right? You should please attend the demo, this basic classes, CMOS basics. Our intention is to discuss only the demo, right? What is, if you don't know, please attend those classes. So connect this gate and gate, because this gate and this gate is connected, right? This gate and this gate is connected. So see, this is a prerequisite. I clearly told this is a prerequisite for PD advance. You should be knowing all these things for the PD advance when you come to PD advance. So this is also done by VLSIGuru only, right? From the basics. So you cannot understand the layout immediately if you are not knowing what? CMOS. So if you know CMOS only, you can do what? PD advanced. So if you're not knowing CMOS, then attend the PD basics course in VLSI Guru. Then we will move forward to what? PD advanced. So when you attend this CMOS basics, then you will understand what is PMOS, what is NMOS, what is CMOS, everything you will understand that. So what you have here, your gate and gate is what? Shorted. So your gate is what? Polysilicon. So for example, if you have previous cell you have layout. That layout you have to connect to this layout. Output of this you should connect here. So you will connect to what? Metal layer, right? So output of this you will connect here to what? Metal layer. But this is a polysilicon. I cannot connect directly. What I will do is I will give one connection also here. Metal connection to this polysilicon. Metal is connecting to what? Polysilicon. So I cannot connect directly. We have what? Contact cut here. This contact cut is used to connect what? Metal to polysilicon. So if any previous I have cell and that cell should connect to this one means it can connect with what? It can connect with metal layer directly now. If you have previous cell, like this, and if you want to make a connection, you can directly make a connection to what? Input. So output of previous cell is connecting to what? Input by using what? Metal layer. So for that reason we have made this connection. So here it is a contact cut. So one more connection is pending. What is that? Your source of PMOS is connecting to what? VDD. Source of NMOS is connecting to what? VSS. So that connection you make. So this is a VDD connecting to what? Source. This source connecting to what? VSS. And this is the contact cut. And this is a contact cut. Sorry, here I don't want here, right? Here I want one contact cut. Here I want one what? Contact cut. Because this source and drain is a semiconductor. N plus N type semiconductor. But this blue color is what? Metal layer. When semiconductor is connecting to metal layer, I want one contact cut. Here also I want one contact cut. So this connection is done. This connecting to VDD. This source connecting to what? VSS. Now this drain and drain is what? Shorting. You short this drain and connect to what? V out. Right? Do that. Connect drain and drain. By using metal layer. Again, I need one contact cut here, right? Because this is a semiconductor and this is what? Metal. One contact cut here, one contact cut here, and here I will give one connection for output that can connect to the next cell. This is the layout of what? CMOS inverter. So this is V in, this is V out. Previous cell, if you have any previous cell, that input is connecting means it will connect to what? The previous cell output will connect to this input. This output will go to what? Next cell input. So connection of all these layouts. Again, this cell output will go to this. Connection of all these layouts is called as what? GDS file. GDS file is having what? Connection of all these layouts. So I have drawn the layout of CMOS inverter. See, the role of physical design engineers is not to draw the layout. That is the role of layout engineers. But still, we should be knowing what layouts consist of. What is consist of? What is this? Purple color is called as what? N-well. This white color boundary is called as what? P substrate. So this blue color is called as metal, right? All these are metal connections. This red color is what? Gate. Gate is made up of what? polysilicon. This yellow color is N plus diffusion, or N plus semiconductor it is, right? This pink color is P plus diffusion, and this black color is metal contact cut, right? Metal contact cut. So this is a layout of your CMOS inverter. So similarly, you have to learn the layout of AND gate, at least layout of NAND gate. See, we are not going to draw the layout, PD engineers. At least you should be having the knowledge what is present inside the layout, right? Layout of, so this is a layout of CMOS inverter, right? So to draw the layout of CMOS NAND gate, first you should be knowing how to write the schematic of CMOS NAND gate. This is a schematic of what? CMOS inverter. First you should be knowing how to write the schematic of CMOS NAND gate. Then you can write the layout for that, right? So all these things you will learn in what? CMOS basics. Right? That is why I told CMOS basics is very important for us. So at last, why I went to this topic called as layout? My GDS file consists of what? Layout connection of what? Layout of cells. All the layout of cells connected, and that's we are going to give to what? That we are going to give to foundry, and foundry is going to fabricate IC for us, not for us, for a company, right? So now, what is physical engineers? See, we are not involved in fabrication, because I told you already, fabrication more than electronic engineers, we need what? Chemical engineers. They should understand the chemical reaction to fabricate. But we are working in what? IC design, and we are working this IC design by using what? EDA tools, and easy EDA tool is a software tool. For this reason only, we have to learn what? Tool command. This EDA tool can understand only TCL. Even your Xilinx tool, which you use for FPGA design, can understand only TCL. But I think you not worked. But if you work right, you can use TCL input for that. And these EDA tools are generally installed in what operating system? Unix operating system, and you will handle many files and folders. So you should be learning Unix basics for that, right? So now, what is the role of PD engineers? What PD engineers do to understand that, right? First, we will go to the basics of what? ASIC design flow. So this is your ASIC design flow. Start with specification, architecture design, RTL design, RTL verification, synthesis, DFT. Right? Till this, from here to here, RTL verification we call it as what? Front end. From synthesis till sign off, fabrication, everything is done in foundry. Till sign off, we call it as what? Back end. So we physical design engineers also responsible to do synthesis also sometimes, right? From synthesis to sign off is called as what? Back end. But from specification to RTL verification is called as what? Front end. So this is called as ASIC design flow. So what happens in this ASIC design flow? We will discuss that. What is ASIC design flow? What happens in that? So what is ASIC design flow? First to start with what? Specification. So what is specification? If an IC has to be designed, right? First we will take what is the blocks required in an IC, right? Blocks in an IC. What we want, like this. ALU is required, GPU is required, CO control unit is required, PLL is required, USB is required, Wi-Fi module is required, Bluetooth is required. So what are all the modules required in an IC, right? First there is an architecture team. The architecture team will take the all what are the blocks required to build an IC, right? So blocks in an IC. Next, apart from the different blocks, what is required? Size of IC, right? What should be the size, estimated size of IC? I cannot design IC however I want, like the size of a TV, right? I should design IC required from the vendor. I should discuss with the vendor what is the size of IC required and what is the max power consumption. See, our intention is to reduce the power consumption. We have to have less power but what is the maximum power consumption? I don't know, right? I am fabricating IC for mobile phone fabrication. I don't know that mobile phone vendor or mobile phone company is using which battery, how much battery is he is using, what should be my maximum power consumption. So we will take the specification of maximum power consumption, speed of operation. Earlier we used to see the blocks used to operate with the speed of megahertz. Now they are operating with the speed of gigahertz. What is the speed of operation? It is not that all the blocks is going to operate with same speed. Each block is going to operate with what? Different clock frequency. Some blocks will operate with lower clock frequency. Some blocks will work at higher clock frequency. Right. So each block, what is the clock frequency, is going to define the speed of operation. Right. Speed of operation. So all these things and estimated cost, everything, right? All these things they will collect for an IC, and the architecture team will build an architecture like this. This is cursor. The architecture team will build architecture like this. What is the requirement of an IC? What are the blocks required, right? And for each block, here there is a second team called as what? RTL design team. RTL design team is going to write what? Verilog or VHDL code for design, right? They'll write Verilog or VHDL code. Now, why this Verilog or VHDL? What is the specialty of this Verilog or VHDL? Yes. What is the specialty of Verilog or VHDL? See, Verilog or VHDL captures the behavior of the circuit, not the structure of the circuit, right? That is specialty of Verilog or VHDL. See, behavior means what? If I ask you people, tell me the structure of mux by using basic gates, how many will tell you? How many of you can tell this structure of mux? Mux is found by using gates, right? Yes or no? This is cursor. Mux is found by using gates. So how many of you can tell me this? How many of you can write the structure of mux? Just give me 1 second. There is some issue. Okay, now how many can you tell the structure of a mux? What is mux? See, mux means what? Mux is having what? Two input and two input mux, right? So it is having what? AND gates and OR gate. So remembering what is present inside the mux is very difficult. But if I ask, tell me the operation of mux or truth table of mux, how many can you tell? Yes, sir. Okay, so sorry for the interruption, right? There was some issue. Right now, okay, now how many, see, this is a mux, right? If I ask, how many can you write the structure of mux? But if I ask, what is the behavior of the mux? What's the behavior of mux? This I naught, I1, what is this? Y, and what is this? Select line. So if I ask you what is the behavior, you can easily tell, right? This is a select line, this is a Y. If select line is 0, Y is going to take what? I naught. Right? If select line is 1, Y is going to take what? Whatever present on I1, that is passed to the Y. This is the behavior of a mux. See, remembering this behavior is easy. That is what your truth table is, right? In your UG class, you have written the many truth table. That is the behavior of a circuit. Right? That is remembering is easy, but remembering the internal structure is very difficult. If I ask D flip flop, what is the internal structure using gates? Remembering is difficult. But if I tell me the D flip flop behavior, whether you can tell what the D flip flop behavior. So you have what pin? D pin, reset pin, clock pin, Q pin. Right? I will ignore Q bar for the time being. So how do you write this? So you have one is reset, one is what? Clock, another one is Q. See, if at all, if your reset is 1, if it's a asynchronous reset, if reset is 1, whatever clock, output will always go to what? 0. If reset is 0, at the positive edge of clock, whatever is present on D, that is passed to what? Q. So I can write Q is equal to what? D, but only at what side? Positive edge of clock. So this is a behavior of your what? D flip flop. So remembering this is easy. But now how many can you tell what is present inside D flip flop? By using gates. You have read latches, right? After latch, you are going to create the flip flop. So your Verilog or VHDL will make you to easily capture the behavior without worrying inside what is present. That is done by synthesis tool. You need not to worry. You can directly write the program, Verilog program, right? I can write Verilog program for mux. Easily I can write. What is that? How to write? If S equals 0, this is 0. What is Y is going to take? Y is going to take what? I not. Else Y is going to take what? I1. Simple. Simply, it is very simple to capture behavior. So how I have captured by using what? If statements. Easy to capture this also. D flip flop. How do you capture? Always at pause edge of clock or pause edge of reset. Right? Begin. If reset is equal to equal to 1. If reset is 1, what is your Q? 0. Else Q is going to take what? D. See, this is going to work only at what edge? Positive edge or positive edge of reset and end. That's it. This is the program for what? D flip flop. It's captured only in 4 lines. So capturing the behavior of circuit is easy rather than remembering the structure. Remembering the internal structure is very difficult. So for that reason, at the beginning what they did, right? They started capturing the digital design by using what? Verilog or VHDL. Easily we can capture the behavior, right? So what is the purpose of using Verilog or VHDL? By using that, easily we can capture the behavior. Easily we can capture the behavior of a circuit. But after writing the program, see, it is very simple, right? For a small program, but very big program, I have written the program for counter, 4-bit counter. Now I have to verify whether this RTL program what I am written, whether it's working as a 4-bit counter or not, right? So to verify that, we have a stage called as what? RTL verification. See here, whatever steps I am mentioning, right? Each step is a course, and each step you can find a job. You can become a RTL design engineer. You can become a RTL or design verification engineer. It is also called as DV, right? Design verification engineer. So there is separate engineer for RTL design. There is separate engineer for what? Design verification. That is front end. So what is design verification and RTL verification? Verifying functionality of a design. All right. Verifying functionality of a design is called as what? RTL. See, design means what? The program which I have written by using what? Verilog or VHDL. It is in what form? Behavioral form. It's capturing the behavior of a circuit. This program we have to verify whether it's working properly or not. Verifying functionality of the design which we have written in Verilog or VHDL is called as what? Design verification. How do we verify? For example, I have written the program for D flip flop. How do we verify it's working like D flip flop or not? Apply input for D, right? Apply input for D. Apply reset as 1. Apply clock edge. What should be the output? As reset is 1, output should be what? Always 0. So verify what is the output. Apply the input and verify the output. Here also, right? Apply the input here. So 0, this is I naught, this I1, this select line, this Y. So 0, 0, 0. What is output? If select line is 0, Y will take what? I naught. What is I naught? 0. 0, 1, 1. What is output? If select line is 1, Y is going to take what? I1. I1 is 1. Y is what? 1. So apply this inputs and verify the what the output you are getting. So applying this input is called as what? This is called as test vector. What is called as? Test cases or test vector. This is called as test cases or test vectors. Apply different inputs and verify what output you are getting. If you are getting proper output, then it is fine. If you are not getting proper output, then tell back what? Go back and intimate your RTL design team that you are not getting the proper output, right? So verifying functionality of a design by applying what? By applying test cases. That is called as design verification. Applying test cases is very easy for mux. If I want to apply all the combination, how many combinations I'll get? Like this, right? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. How many combinations I'll get? These inputs. 0. What are the inputs I have here? These three inputs, right? If I want to apply all the combinations, 0, 0, 0, 0, 0, 1, 0, 1, 0. I'll get how many combinations? 8 combinations. I'll get 8. Totally 8. 8 means what? 2 power 3. What is 3? Number of inputs, right? That's nothing but equal to 8. If I have 64 inputs, then it will become what? How many combinations I'll get? 2 power 64. I cannot apply all the combinations, right? Then the role of design verification engineer is what combination of inputs I should apply so that I can verify all the functionality of the design. Entire functionality I can verify what combinations I should pick. So intelligently he has to pick the combination of inputs because we cannot apply all the input combinations to test the circuit. What combination of inputs I have to apply so that I can test entire design. Right? He has to make the decision. So that is told by a methodology called as UVM, Universal Verification Methodology. So design verification engineers should also learn what? UVM. So UVM means Universal Verification Methodology. This is going to tell how to apply the inputs for the complex design. See, now we are discussing about D flip flop or simple flip flops, but we are discussing for now complex flip flop. If you have a complex flip flop, what inputs you have to apply? How to apply the inputs so that entire functionality can be covered. So that is told by what? UVM Along with UVM, they should also learn system Verilog. So this both they have to learn along with Verilog. Verilog is compulsory required. Along with that, they should learn UVM and system Verilog to become what? Design verification engineer. System Verilog is nothing but Verilog plus C++. Whatever you have in C++, right? Those concepts are included in Verilog. That is called as what? System Verilog. So here this is a separate course, and here also you will see many engineers getting into VLSI domain. So after this, right, you have, so your design is in what form? Your design is in, this is only for verification, but your design is in what form now? It is in BRL form. It is in Verilog or VHDL, and it is in BRL form. This BRL form you cannot give to the foundry. Foundry is going to accept only what? GDS and it's what? Layout of cells. But design is not even in the form of cells. It is in the form of cells. Means what? Cells means gates. Another form of another name for cell is what? Gate. So here foundry is not going to accept even this Verilog or VHDL. So next what we do is we convert this BRL form to the gate level form. One step. Not directly to the layout level. We'll go to what? Gate level. That is called as what? Synthesis. Synthesis convert RTL code to gate level netlist. I'll tell you what is netlist. Now, for the time being, you understand gate level diagram. Right? So convert this whatever program you written in RTL, that is Verilog or VHDL, convert to what? Gate level, gate and its connections. Gate means you know right what is gates? AND gate, OR gate, XOR gate, NOR gate, NAND gate. Convert to that. So now we will, what is inputs for synthesis? So there is a tool for synthesis. You are not going to do synthesis. Tool is going to do that, but you have to give proper inputs for that. What is our tool name? Define compiler from synopsis and genus from cadence. This is from synopsis and this is from what? Cadence. See, you will work both the tools in industry. One company will work, for example, if you go to Intel, they will use synopsis tool. But if you go to Qualcomm, they will use what? Genus. Both the tools you are going to work in future. But now you will learn only synopsis tools. There is no difference between one tool to another tool. Only commands will change. For commands, there is a user manual. If you see the user manual, you can find the commands. What is the command? And nowadays, you need not to use the command also. There is a flow developed by industries. Industry have developed a proper flow. If it shows the flow, you can sleep happily. And the flow only will take to the entire 8 hours of run. It will complete. It's not so easy like that, but the flow is there. Very good flow is there, right? PD physical design is semi-automated. Now everything company have written the automated scripts. Everything the scripts only will do. Our role is to identify where we are getting the errors, why we are getting the errors, what is the reason for those errors, how to fix the errors. So if you understand the error and if you have very good experience, you can fix the error in 2 minutes. If you're not understanding the error and if you're not able to identify the fixing, even 20 days also you cannot fix the error, right? So physical design engineers error experience is very important. Experience if you have, you can easily identify the errors. What is the problem? Why it is happening? So I have seen this type of problem earlier also. Okay, I will fix it. But at the beginning, it is little bit difficult, right, to understand what is the error, how to fix it, why we are getting this, everything, right? So we are using tool as design compiler, and from the cadence is what? Genus. So now, what are the inputs for synthesis? Input. So one input is your Netlist is not, it's output from RTL, right? Your RTL code, whatever you written, Verilog or VHDL. This code only have to convert to the gate level, right? That should be one of your input, your RTL code. This RTL code is in the form of what? Verilog or VHDL. In what form? In behavioral form. This is one of the input. Now you will take this code, you will convert to the gates. Then what gates you have to use? Who is going to tell that? Take this code, convert to the gate. What gates you can use? Whether you can use D flip flop, whether you can use SR flip flop, whether you can use T flip flop, whether you can use counters, whether you can use NAND gate, NOR gates. Who is going to tell that? What gates you have to use? So that gate information is present in a file called as what? Library file, or it's also called as what? Liberty file. Its extension is .lib. This extension is what? .v. .v means it is a, after file name you will be having like this. For example, counter.v, dflip.v. Here you will be having extension called as what? .lib, tsmc.lib, like that, right? So this liberty or library files is going to tell what cells you have to use during the synthesis. So generally you will be using standard cells. So generally this file will be telling standard cells. Standard cells means it is like your NAND, NOR, XOR, OR, AND, inverter, buffer, mux, D flip flop, all those things. So these are the basic gates, right? So these gates information will be present in what? Liberty file. What information will be present? This information means it will be having standard cell information. This file will be having standard cell information. In the PD advanced class, you will open this file and you will understand each line, what is present in this file. Each line you are going to understand in PD advanced class. So, what information is present for this cells? What type of information? Like what is the area of this cells? What is the functionality of this cell? Functionality means NAND gate. What is the functionality? Functionality of NAND gate. NAND gate is nothing but A. A is one of the input. So y is equal to A and B, the whole bar. Whole bar we will write by using what? Exclamatory mark here. This is the role of what? NAND gate. What is the role of your XOR gate? A plus B bar. Sorry, it's not plus, right? A and B bar plus A bar and B. This is the functionality of your XOR gate. So this functionality information and delay of the cell, how much delay this cell is, means after applying the input, after what time you will get the output. What's the delay of the cell, and you will be having what is the power consumption of the cell, how much power each cell is consuming. So these informations are present in which file? Library or liberty file. Your synthesis tool will pick the cells from what? This library or liberty file. What cells is picked from that only it's going to convert what? RTL to gate level netlist. So you have one more input for synthesis. What is that? So HTC file. What is HTC file consists of? So you have design constraints, right? So you have many design constraints like clock period mainly, right? Clock period Means your design should work with what clock frequency. So period is inversely proportional to what? Clock frequency. Time period is T is equal to 1 by F. So till now in the Verilog file you have not mentioned what is a clock frequency. So in HTC file you are going to mention what is a clock period. With what clock period this design has to work. That constraints you will give. Clock period. So again after clock period you have many constraints like set input delay, set output delay, set driving cell, set max transition, max capacitance, all those things you have. So these things you will learn in the advanced part of physical design. If I tell also you not understand now, that is a step-by-step process that you'll understand in the advanced part. So all those constraints present in what file? HTC constraints file. So for the timing you understand that clock period. So this HTC indicates that you synthesize the design, means convert your RTL to gate level netlist, but you have to meet this clock period. Your design should work with this clock period. Your design is working with clock period or not. To verify, we do what analysis? Setup analysis. There is analysis called as what? Setup analysis. That also you will learn in advanced physical design. So this is going to identify whether your design is working with what? This clock period or not. If your clock frequency is 1 gigahertz, your design should work with 1 gigahertz clock frequency. See, doing synthesis is very easy. Converting RTL to gate level netlist is very easy. But converting with this constraint rate is very difficult. That they are the challenges we have. Engineers mainly we have challenges here. See, if your parents is going to tell that go to VLSI and Guru and come back whatever mode you want, you can easily book a cab, come here, easily book a cab, go to home. It's very easy. If they tell go and come back within 20 rupees, it's very difficult. There's a constraint of 20 rupees, right? I have to go and come back within 20 rupees means very difficult. Similarly, synthesize the code to operate within this clock frequency means very difficult. So then we have to do multiple app options we have to set, multiple iterations we have to run. So to see that my design is working with this clock frequency, right? That is why it is called as what? Synopsis design constraints. It's putting constraints on the design. So these three are the input files for synthesis. Then what is the output? Output of synthesis. So it is gate level netlist. So what is this gate level netlist then? So gate level netlist is also a Verilog or VHDL program. Then what is the difference there? Right? See, how many know Verilog here? At least basics of Verilog. So Verilog is also not a part of UG courses. Verilog was there or not? Yes, sir. Gate level netlist is also if Verilog is not there, then we should also do some basic Verilog course, small, just how to write a module, how to give the input, that we have to include in the basics of. If you are not a part of UG course where Verilog is not done, then please approach the admin. One day, at least one day, we should do some Verilog basics, right? For physical design, knowing Verilog is not important, but at least you should be knowing basics. So what is gate level netlist then? Your RTL code is also Verilog or VHDL. Your gate level netlist is also Verilog or VHDL. Then what is the difference between both? See, in gate level netlist, you should be having only gate, and its connections. Only this should be the part of your gate level netlist, nothing apart from that. RTL can have anything, if statement, case statement, procedural statement, assign statement, anything can be there. But gate level netlist should be having what? Only gate and its connection. See, we will take an example here, right? You take this example, you have at the beginning one input M, N O, right? M and N is going to one AND gate. This AND gate is having pin A, B, and what? Y. And this O is connecting to one OR gate. This is a diagram what you're getting after synthesis. This is again the pins are A, B, and Y. This OR gate is having input pin A, B, and Y. I am not going to decide that. This is defined in the .lib. Whatever I told .lib, right? It is defined here. And you assume that it's going to connect to one inverter. And this inverter is going to connect to output P. And this is A, this is B. So how to write the netlist for this? So to write the netlist for this, the same procedure we follow. Module. Module is a starting keyword in Verilog. Module name. Any module name you can use. I am using temp. I have to declare the inputs. What are the inputs? I have M, N, O, P. So again I have to declare the inputs here. What are the inputs here? Input ports are M, N, O. Output ports are just output. I have written outputs and inputs, right? S should be removed here. Okay. P. And I have intermediate signals also, right? This is one intermediate signal, another intermediate signal. So that I called as N1 and N2. This intermediate signal should be defined as what? Wire N1 comma N2. This is same. RTL also having the same thing. My netlist is also having same thing. After this, right, netlist should have only gate and its connection. First I will start with first gate. What is the first gate I have? AND gate. So we assume that this AND gate name is AND 2. This name is present in .lib. I should use same name. For this AND gate, what is the name present in the .lib file? This liberty file. The same name I should use here. This name we assume that it is R2. This name is INB. So what is the name of AND gate? AND 2. And this is a name of the AND gate in the library file. And my synthesis tool will give one instance name. Instance name is what? U1. This name is given because in my design I may be having n number of AND gates, not only one AND gate. I may be having 10 AND gates. From one AND gate to another AND gate, I should be having some differentiation, right? So for that reason, my synthesis tool will give one instance name. What is the instance name of this gate? U1. Instance name of this gate is what? U2. Instance name of this gate is U3. It can give any name. Now I am taking it as what? U1. Next I have port mapping. Port mapping means this A pin is connecting where? It's connecting to M port. Correct? A is connecting to where? M. So dot of A of M means A pin is connecting to what port? What port? M. See, input and output of this entire block is called as what? Ports. Input and output of this cell is called as what? Pins. Here A, B, Y is called as what? Pin. M, N, O, P is called as what? Ports. So A pin is connecting to M port. Similarly, B pin is connecting where? N port. Y pin where it's connecting. This is net. Intermediate signal is called as what? Net. It's connecting to where it's connecting? N1 net. Right. Y of this AND gate is connecting where? N1 net. Right. Done. Next, you declare, define next gate. What is the next gate? R2. What is the instance name? U2. So A pin where it's connecting? This A pin is connecting where? N1 net. B pin it's connecting to O port. Y pin it's connecting to N2. Next, at last I have what? One inverter U3 instance name. This A pin where it's connecting N2. This B pin where it's connecting P port. At last I should be having what? End module. So this is the netlist. This netlist is having gate and its connection. Apart from that, I should not be having any assign statement, not if statement. I should not be having any case statement, not procedural statement. Only I should be having gates. Only you can see gates here, right? And its connections, right? Connections is present, correct? Because this Y pin of AND gate is connecting to which net? N1 net. And A pin of OR gate is connecting to which net? N1 net. This clearly indicates that output of AND gate is connecting to what? Input of OR gate. Without seeing this diagram also my tool can understand this, right? Because output Y pin is connecting to N1 net, input of OR gate A pin is connecting to N1 net. This clearly indicates that output of AND gate is connecting to what? Input of OR gate. Similarly, output of OR gate is connecting to what? Input of inverter. This is the connection maintained here. This is called as gate and its connection. This is what the netlist is. Now you have converted your design from RTL code to what? Netlist. Next, you have to convert your netlist to layout form. That is the role of our physical design engineers. That we will see after the break. Alright. So we'll take a break now for 15 minutes. Now the time is 11:40. Take a 15 minutes break. We'll continue after the break. After the break, we'll see what is physical design and what we do in physical design. So till now we have converted the behavioral form to gate level form. Next we have to convert this gate level form to what? Layout form or physical form. That is called as physical design, right? So that we will see in the next session, next half. Okay, again now the time is 11:40 in my system. Accordingly, you match your time 45, 50, right? We'll again come back at 11:50. 10
Yes,
minutes
sir.
almost.
Around 12 o'clock, sir.
11:50. Exactly
Okay, sir.
11:50. I'll start.
Thank you. 22 members sit in the good. Tarun Kumar, are you there? Tarun Kumar, L. Tarun Kumar,
Yes, we'll continue again, right? Now, physical design. See, physical design, as I told you, right? We cannot do physical design directly for 3 crore cells. Max to max, we can do for 30 lakhs or 40 lakh cells. That too is a lengthy process. It will take 5 to 6 days to complete entire runtime, right? So, first, what we start with this physical design is we start with partitioning. So, what we do, right? So, in the netlist, I have cells. Netlist is giving me all the cells, right? I have totally 4 core cells. What we do, entire chip, whatever I have, this chip we partition into different blocks like this. So this is one block, A block. This is called as what? B block. This is C, D, E, F, G, H, I, J, K, L. So each block will be having a cell count of around 10 lakh to 30 lakh within that range. Every block will not be having same cell count. It may vary between 10 lakhs to 30 lakhs. With this range of the this range, right? They will divide the entire chip into different blocks, right? So first we will start physical design of each block. See, there will be separate netlist given for each block. So A will receive his netlist and B will receive his netlist, C will receive his netlist. So we engineers, when we go to industry, right, we work on what level physical design? Block level physical design. The person who is fitting this entire chip into block, different blocks, this entire chip, those are called as top level designers. This is what? Top level designer. Or they are called as chip top designers. Alright? So chip top, they will work at full chip level. So they are responsible for dividing into what? Blocks and integrating all the blocks. So we at the lower level of experience will not work at the chip top level. We work at what level? Block level. So when you have experience like 7 years or 8 years of experience, then you will work at what level? Chip top level or full chip level. So first each engineer, right? Each engineer is given one block. One engineer will take A block, another engineer will take what? B block, another engineer will take what? C block. Each engineer will start working on his own block. So each engineer will get its own netlist, right? Entire netlist again they will divide into for each block. So A engineer will get his own netlist, B engineer will get his own netlist, C engineer will get what? His own netlist. So in VLSI Guru, we will do block level physical design. So first step in physical design is what? Partitioning like this. Entire full chip is divided into what? Different blocks. See, there is a chance that this full chip may be divided into subsystems also, right? Not only directly blocks. They may first divide into subsystems. Some companies, if the chip is very big, what they do is first they divide into subsystems like this. 4 subsystems. This is one subsystem handled by one lead. This separate second subsystem handled by one lead. Third subsystem handled by one lead. Next subsystem handled by one lead. Again, this subsystem again is divided into what? Blocks. These subsystems, they will divide into what? Blocks. So here what they do, from the blocks, first they will integrate what? They will form subsystem, and from the subsystem they will form what? Complete chip. Now here the role of full chip level design is very easy, because his role is to only integrate what? He will not worry. For example, you assume this person, this is subsystem 1. Subsystem is now divided into what? Different blocks: A, B, C, D, E, F, G. I have different blocks here. The role of this subsystem engineer.
పంచేయాలా నేనే వెళ్ళి పింఛన్ డబ్బులు కూడా నేనే పంచాలా.
అవునా నిన్న బీటెక్ ఎక్కడ అక్కడేనా సిద్దిపూర్ పెట్టేనా వేసింది?
అక్కడ
Yes, please mute your
డైలీ
this
సర్వీస్.
one, right? If you are not talking to me, please mute. So this entire subsystem is having what? Different blocks. The what role of subsystem engineer is now little bit reduced, right? What is the role? His role? Integrate 1, 2, 3, 4, 5, 6, 7 blocks. This subsystem engineer will integrate what? All the blocks. He will integrate all the blocks. He will integrate all the blocks. What is role of full chip level engineer? Integrate all the subsystems. So if the chip is very big, they may divide into subsystem first, then they may divide into what? Blocks. Right? Then you will be working in particular subsystem and particular block. Or directly a chip can be divided into what? Blocks. If chip is very small, they will directly divide into what? Blocks. If chip is very small, directly they will do physical design for chip only. They will not divide into blocks. If chip is having only 30 lakh cells, they are doing only physical design for small chip. It's having only 30 lakh cells. Then why they will divide into blocks? They will do physical design directly. If they have, if the entire chip is having more cells, then they'll divide into blocks. Each physical design engineer will do physical design of each block. So now you will work on block level physical design. So we are working on what it is called as block level physical design. So physical design first starts with partitioning. After partitioning, you will get what? Blocks. So partitioning means what? What is partitioning? Divide chip into blocks, and each blocks will be having how many cells? At 1 to 3 million cells. 3 million means 30 lakhs, right? Now after that we will start with block level physical design. So in this block level physical design, right, we have many steps in this. So the steps is as follows. First is floor planning. Next is placement. Next is CTS. CTS means clock tree synthesis. Next is routing, and next is sign off checks. So these are things present in block level physical design. Again, floor planning has these many steps. What is that? Creating core area, and die area is also called as what? Block area. Die area is also called as what? Block area. Second, you create. Second is port placement. Next is macro placement. Next is power planning. So these are different steps in floor planning. So this is first we have to create for the entire block. we have to create what? A core area and die area like this. This like this. So this entire inside line is called as what? Core area. Outside line is called as what? Die area. So I have to create a core area, and we have to create what? Die area. So inside this core area, all my standard cells will sit. Layout of standard cells. See, we are not going to draw the layout. My netlist is showing the cells, right? Here, I've shown the netlist. My netlist is showing the cells here. These cells are present where? .lib. For all the cells present in the .lib, there is one more file called as LEF file. What is that file called as? LEF file. That LEF file consists of layout of all the cells. We are not going to draw the layout. Layout is drawn by a layout engineers. They will draw the layout and they will give in a file called as what? LEF file. So those cells we are placed inside. We are going to place inside the core area, but not now in the placement step. Those are layout of cells, right? But at the beginning, we'll create core area and die area. This is core area, and outside part is called as what? Die area. So this core area and die area we cannot get directly, right? We should occupy this area should be not very big or very small. It should be sufficient enough to occupy all the cells. What are the cells required for my design? How many cells present in my netlist? Those many cells this core area should occupy, and it should not be very big unnecessarily, right? And you are not going to create core area and die area. Who is going to create for you? This is your A block. This A block person is going to create what? Core area and die area for you. Whatever he is created, that is chip top, I can tell. What is this top? The person who is working at the full chip level or at the subsystem level, he is called as what? Chip top. Chip top is going to create you. You are not going to create that. You are going to follow his instructions, right? You can see what is the shape of your C block. C block is having which shape? Something like inverted L shape, right? So always block core area and die area need not to be in rectangle shape. It can be even in what shape? L shape. It can be even in T shape. It can be even in U shape. Any shape it can be. That you are not going to create it. Who is going to create it? Chip top is going to create it. As per his instructions, you should create the core area and die area. What shape and what area is specifying. Even he will give the commands also to create. If you source that command, it will create it. It will automatically do. But here in our thing, there is no chip top. We will tell how to create. What are the commands used? How to use the commands? Everything we'll discuss. Not about physical design. How to create this? How to create this core area and die area, right? How to create by using different shapes. So if I want to create this core area and die area in this shape, how to use a command? This core area and what is this? Die area. If I want to create in this shape, how to use the commands? So everything we will discuss in advanced class. So first step is what? Create core area and die area. So what is next step? Port placement. So I have inputs of the block, right? Here you can see the inputs of the block, input and output of the block. What are the inputs here? M and O, and what is output? It is called as ports. Here just we are representing, it is a just logical representation we are representing by alphabets. But here we have to represent physically. Physically means ports are represented physically by metal layers. I have to place these ports. Ports are what? These are what? Metal pieces. I have to place the ports here. So place the ports in between core area and die area. You are going to place the ports. And these ports also where to place. You are not going to decide. Who is going to decide? Chip top. Because, for example, if your A block is communicating with B block, means output of A block is going to what? B block. Then all the output ports you will place here. Right? You have to place all the output ports here because output ports easily can go to what? B block. And you are getting all the inputs to A block from D block. Then all the input ports you place here. Yes or no? So where you have to place your input ports, where you have to place your output ports is decided from whom? Chip top or the block level design. According to his guidance, you should place the ports. If he's asking to place at the bottom, you have to place at the bottom input ports. If he's asking to place at the right hand side, you should place at the right hand side. So in our course, we'll see how to place the ports wherever he is telling, chip top is telling. If he's asking to place the port at the bottom, how to place it. If he's asking to place the port at the top, how to place it. So we'll see all the commands, we'll discuss that. So that is what called as port placement. Next is macro placement. So what are macros first of all? See, we have standard cells, right? AND gate, OR gate, XOR gate. Similarly to that, we have some complex cells which are already designed and you have to redesign it, right? See, you have a sambar powder or puliyogre mix in your home. When your mother is preparing this puliyogre, she will not prepare this puliyogre mix from the scratch, because that puliyogre mix is already available in the market. She will bring that easily. She will mix in what? She will mix in the rice. What is the advantage of that? Is her time is saved, and even the taste and quality is good. They may not get the same quality. If they are getting, they will do from the scratch only. If they feel that this quality is good, they'll directly do that. The same thing is also called as macros. See, what are macros? There are few designs there are few layouts already available. In the previous project, there are few blocks. You assume that in the previous project I have like ALU block. This layout is already available. In the previous project, I also have SRAM block. I feel that this SRAM block is very good. In the previous project, I have already done the physical design of SRAM block. This is a bigger chip I am using. That chip that is very good. I will reuse that layout. Why for this SRAM? I will not write the Verilog code from the beginning. I will not do the synthesis. I will directly use the layout of that. For this ALU block, some block is there, right? I will not write the Verilog code. I will not do the synthesis. I will directly reuse it. So then what is the advantage if I reuse? Is time saves, and for example, with ALU, SRAM, I have 20 lakh cells. 20 lakh cells I have, right? Along with 20 lakh cells, SRAM is one cell, big cell it is. ALU is L cell. How many cells I have? 20 lakhs, 2 cells, right? 20 lakhs plus 2. This many cells I have in design. For ALU, if I write the Verilog code and if I do synthesis, this ALU will produce again 10 lakh cells, right? 10 lakhs standard cells, I will tell. Cells means what? AND gate, OR gate, XOR gate, mux. This what is present inside ALU, I'm not worrying, because I am feeling that this ALU is good and I'm already having layout of ALU. If I write the Verilog code for ALU and if I do synthesis, this ALU will produce how many cells again? 10 lakh cells. Along with this 20 lakh, this cell 10 lakhs will also add to my account. Totally how many cell count I have? 30 lakhs. If I directly reuse the previous designs which are already available, then I can reduce what? I can reduce the cell count. If cell count is reduced, my time will save, run time will save. While doing physical design, run time will save. So reusing the previous designs which are we feel which is very efficient, those are called as what? Macros. So I first will do this macro placement. Macros are complex cells and which are already optimized, that we'll place first. Optimized means which are already having the better result, best result. Another word for optimize is improvement. Already they are improved, right? Already if I have the layout for that, means first I'll place those macros, right? So we'll do macro placement next. Why we do macro placement first? Because these type of macros, right, it will be in less in count. It will be varying from just the count is just between 0 to 100. In rare case, you will be having more than 100. It will be just within what? 0 to 100. But the standard cells, how much count you will be having? It will be in millions. It will be in lakhs. So for that reason, first we do macro placement because its count is very less. Hardly we will be having 20 to 30 macros in the uniform case. In some cases, you will be having hundreds or 70s, 80s. In very rare case, you will be having 200 or 300 macros. First, you will do macro placement first because the count is very less. First, we will give to these places for these macros, right? For that reason, we'll do macro placement first. Then, what is the next step? Power planning. See, we have to efficiently plan the power because you see here, right? All the cells, this macros, all the cells requires power, right? VDD and ground. If I place the cells here inside core area in the placement step is the next step. If I place this millions of cells inside core area, all these cells should get what? VDD and VSS connections. And even with less IR drop. IR drop is very important. Power planning, right? We should have with less IR drop. Is very what is IR drop then? So you assume I have a port here. At the port, the VDD is 1.5 volts. See, at the lower technology, the VDD will be 1.5 volts only. It is not like 5 volts or 12 volts, what as you see in the UG textbooks. The VDD value will be what? Because we are working in 3 nanometer technology. We cannot operate the cells with 5 volts or 12 volts. We are operating the cells with what? 1.5 volts. I have one cell here. So this VDD, I am connecting to this port through what? Metal. This is a metal connection. Now here I have 1.5 volt. This metal layer is having some resistance, right? It's having some resistance. Internally it is having some resistance. And current is flowing through this, right? This cell is drawing the current. Current is flowing, I is flowing. So V is equal to what? I into R. What is R? Resistance of the metal layer. And what is I? Current flowing through this metal. So V is equal to I into R. It is nothing but what? 0.3 volts. You assume what is it? 0.3 volts. This 0.3 volts is going to drop on the metal layer. This whatever drop happening on the metal layer is going to convert in form of what? Heat. That voltage is lost. It's going to convert in form of heat. Out of 1.5 volts, 0.3 volt is lost in form of what? Heat. How much volt is reaching here? 1.2 volts. So entire VDD is not reaching. This is called as what? IR drop. This IR drop is happening because of what? Metal layer resistance. So if this less value is reaching here, right? If the small value, very less value is reaching here, what is the problem? We have more cell delay. Cell delay increases. What if I have 1.5 here, 1.5 only should reach here. So what action we can take to do that? That is called as what? That we do it in what? Power planning. We create stripes, we create rails. From stripes we connect to rails, right? That we do in power planning. So how to efficiently give the power to all the cells without this IR drop? That is what we do it in what? We do it in power planning. So after floor planning, you will be having core area, die area with macros. What? Macros are placed and ports are placed and power planning is done. Right? What is the next step you have? Placement. So placement means place all the cells inside. Place all cells inside core area. All the standard cells we are going to place inside core area. We are going to place like this. So what are this? Layout of cells. Layout of cells we should place inside the core area. So we have millions of cells. This millions of cells we will place inside the core area. After placement step, right, we will do the checks, right? We will do placement checks. After each stage we have checks, so we will do the checks like congestion means whether my placement is good or not. See, these cells are placed but not connected, so congestion is going to check whether I can connect all the cells or not. Means if this cell is connecting to this cell, if this cell is connecting to this cell, they cannot be placed very far away, right? Then my connection becomes what? Very difficult. So congestion is a check, is going to verify whether all the cells can be easily connected or not. So this is what the congestion will do. So we are going to do congestion, we are going to do setup and hold check. We are going to do max trans, max cap violation, trans, max cap violation. If you have anything, right, all those checks you will do after violations, right? We are going to check after what stage? Placement stage. If this is fine, then only we go for what? CTS stage. So what is CTS stands for? Clock tree synthesis. See, in clock tree synthesis we build clock tree using inverters and buffers. That is what the role of CTS. Why we have to build here is, so this is your, at the beginning one clock will be counting to what? All the flip-flops like this. This one clock is counting to all the flip-flops. So the load on the clock pin is what? Very high. To reduce the load on the clock pin, we do clock tree synthesis like this. This clock is counting to what? Only one buffer. Now from this buffer we count to what? Only two buffers. This buffer is counting to what? These two buffers. And this buffer is counting to what? Only three flip-flops. So like that we have to build the clock tree. If you build clock tree like this, then only I can see proper clock transition. I will get proper clock like this. Or else I will see clock like this. There is no on time in this clock. What is happening? There is no on time and there is no off time. If I build a clock tree only, I can see what? On time and off time. So why is that? So all those things we will discuss during what? Advanced class of physical design, and how to do all these things in by using tool. How to build this clock tree by using tool, that we discuss in advanced part of physical design, right? And last step is what? Routing. What is routing? Connect all cells, macros and ports by using metal layers. Right? Connect all the cells, right, like this. By using metal layers, you connect it. So even with macros also, right? Macros will connect to cells. So after connecting this, we will do what? Sign off checks. So after each stage we have checks that we'll see what in the advanced part. After that we'll do what? sign off checks. So again in sign off checks we have 3 different checks. So that is IR drop and EM violation check. So IR drop means what? As I told earlier, right? There should be no more IR drop. IR drop means if this is 1.5, cell should also get what? VDD 1.5. So there should be no more IR drop. If IR drop is happening, so we should see why this is happening. So this is not done by using ICC2. Right? Physical design is done by using ICC2. This is physical design, right? Physical design we use tool called as what? ICC2 by Synopsys and Innovus from Cadence. But this sign off checks are not done using what? ICC2. This is done by using a tool called as what? Redoc. Separate tool it is. We cannot see in ICC2. Next is, see here we check IR drop. EM means what? Electron migration. See every metal layer has its capability of conducting current. If it is conducting more current than its limit, this metal will melt away. That is called as what? Electron migration. See in the design, if this metal is conducting more current, more than its limit, if this metal is melting away in an IC, then this connection is lost. Your IC will not function. So EM check is going, in EM check what we do, every metal in an IC is going to conduct the current within its limit or not. We are going to check. If it's going to conduct the current more than its limit, then error will be flagged and we have to fix those errors. So that check is done here. EM means all the metals are conducting the current of its limit or not. If it's conducting more than its limit, the metal will melt away. The same concept we are using in fuse, right? In home, we have fuse. If you open your MCB in the home, in older MCB, we'll be having thin wire here. This is a MCB. You'll be having thin wire like this. If more current flows, right, this thin wire will what? Melt away. So that this high current will not reach to your appliances. Your appliances are safe. If this is melting away, automatically is going to cut the current for your home. Or if the high current is flowing, if there is a variation in this if there is a variation, there is a trip will go down. Immediately it will cut the, if this is cutting, right, if this cuts, what happens? The trip will come down immediately. If the trip is happening, automatically there is an indication that high current was going inside, it has been stopped. This high current will not reach your appliances and your appliances are safe. That is what the concept they use in fuse. The same thing we also check here, whether all the metal layers are conducting the current not more than its limit, should conduct within its limit. Next we do STA checks or sign, we call it timing sign off. We use this by using what? Prime time and star RC. We use these two tools, prime time and star RC, to do this check, the STA check. So in STA we do checks like this one, right? Whatever I told earlier, doing CTS, setup and hold checks, max cap, max trans. So first we'll discuss all this theory, then we'll do what? All this checks. So like multi-cycle path, and false path, crosstalk, asynchronous paths, SDC. How to write SDC? I told you, right? This one, right? How to write this SDC file? So MCMM, right? Multi-mode, multi-corner, MCMM, file discussion, right? All these things we do it in what? STA. So all this discussion is done at the beginning only, right? But I'm mentioning here. Again, at the end, we do this STA checks. This is called as timing sign off. Instead of STA check, I can write it as what? Timing sign off. So at last, we do what? Physical verification, PV, right? Physical verification. So in physical verification, we are going to check DRC, LVS. DRC means, so between one metal layer to another metal layer, there should be some spacing, proper spacing. So we should be maintaining what? Minimum width of the metal layer. So there should be minimum spacing. This rule is defined from the foundry. We have to maintain this rule between the metal layers. If we are not maintaining, then we'll get what? DRC violations. If any metal layer is shorting with other metal layer, right? Then we get what? Shorts. So all these checks we do in physical verification, whether my routing is clean or not. Like antenna violations, whatever you have, antenna violation. So that is that we are going to check. So that you will discuss what is antenna violation. So that type of checks is called as what? Physical verification. Physical verification means whatever the routing I have done, metal routing, whether it's going to follow all the rules or not, foundry rules. If it's not following the foundry rules, then the error will be flagged. Then we have to fix it. So this is done by using a tool called as what? IC validator. So, but industry will use a tool called as what? Caliber. Industry will use a tool called as what? Caliber, but we are using what? Because Caliber is from mental graphic, it is not from Synopsys. IC validator is from Synopsys. So this sign off checks is done for all the blocks. After that, what happens? Blocks are integrated to form what? Full chip, and they will take SDC from full chip, not SDC, GDS from full chip, and this GDS is given to foundry, and foundry will fabricate IC for us, right? So here standard cells, whatever we have placed, this is layout of what? Standard cells. We are not going to draw the layout, but still we should be having idea what is present inside the cells. So this is what layout of a macros, right? So this is this is what we cover in physical design. So in advanced physical design theory, we discuss all this theory concept. In the lab, we do two projects. One project is done with help of what? Mentor. Other project we will give to you. You should do it, right? So two project is done. In one project, we do all these steps step by step. So 3 months we are going to do all these things, right? So this is about the demo class. I'll stop here, and at the final, if you have any queries, you can ask me. So if you don't have any queries, you can go. If you have any queries, you can ask me. Ah, TCL is scripting language only, right? Other than that, it's not covered in this. You don't want anything to learn apart from this. See, you have scripting languages like Python and Perl. Python and Perl is not used every time. See, if you want to do file operations, your tool first of all cannot understand Python and Perl. Any tool. But Python and Perl is still used to do file operations because I want to read some data from the file. That even you can do by using TCL. But Python and Perl you can do easily. If you know Python and Perl, right, you can do easily because Python and Perl has good constructs to do all these things very easily compared to TCL. For that reason, you want TCL, Python and Perl. So if you know Python and Perl, it is good. But TCL must and should you should know. So we are going to cover TCL. Without TCL, if you know Python and Perl, you cannot do PD. You should know TCL. Python and Perl is just a added advantage. If you know, you can do. But till now, I am working, right. I have never used Python and Perl. I am using only. So even I know Python and Perl. I don't know Python in larger extent, but I know Perl. But I have never used it because that type of situation I didn't get. But TCL we use every time because tool can understand only TCL. If I want to discuss anything, if I want to get from tool, I can interact only with TCL. So TCL is very important to focus on TCL most. If you want to build a big flow, then you can use what Python and Perl just to do the file operations, to do get the information from a file. For example, I have a big hundreds of files. In hundreds of files, I want to extract one line where there is a keyword called as create core area. From all the 100 files, I have to extract that. Open the file, copy that line. Open the file, copy that line. 100 times you have to do. Instead of that, you can easily do by using what? Scripting languages. Python, Perl, or TCL. You can do by using TCL also. But better you can do it in Python and Perl. That is the advantage. Only for that purpose, we can use Python and Perl. But in this course, we are going to teach only TCL. See, TCL again, basics is taught in what? Basic course. In advanced PD, we are going to use advanced TCL. Advanced TCL includes this basic TCL plus tool command languages. ICC2 is having their own its own command languages. Mixture of that we are going to use as advanced TCL. So advanced TCL will do. In how to use this TCL in this entire project, we are going to use TCL. We are going to write many scripts, TCL scripts in advanced course. Yes, any other doubts you have? See, we are using Synopsys tool, right? I have mentioned, I think each and every step I have mentioned what tools we are using. So we are using Synopsys tools. See, market is mixture of both Synopsys and Innovus tools, Cadence tools. So anything you can use when it depends upon which client you are working. Right? Depends upon that you will use any of the tool. If you go to Intel, you use only Synopsys tools. If you go to Qualcomm, you use what? Innovus. It depends upon which company and what tool they are using. My suggestion is first learn one tool completely. Based on that, right, you can compare with other tools. Yes, STA is part of STA is part of this. Without STA, physical design is nothing, right? STA is done along this course, right? All these topics are covered. See, whatever tool you are, I have mentioned all the tools you will get. DC compiler, ICC2, prime time, star RC, IC validator, you will get, but Redac we don't have. Right? Only theory is covered for this. We don't have Redac license. So I think, see, please don't ask the questions which I have already told. Please ask any new questions. Right? I have clearly told that we are going to do 2 projects. So one project is done during the lab. Lab is nothing but starting of the project and ending of the project. One complete project which is going to take you to all complete cycle from physical block level, physical design till what? Sign off checks. It's going to take through all this cycle, one project. One project is given to you to do your own, but students will not do that because before doing that only they'll get the job or they will be busy in answering, preparing for this mock interviews. So if you are ready to do one more project, Institute will give you. Because see, after completion, of course, you have to take the mock interviews. You will be busy in preparing for. See, I also suggest that because don't involve yourself in only doing the projects. Also, prepare for the interviews. Like, if the question is asked, explain ASIC design flow. You should be explaining all the steps. Stand in front of mirror, answer the questions, right? And I see many students are weak in communication. So practice that. See, after coaching period, I already discussed, right? Please go through the video if it is giving. See, aptitude is not covered here, right? We are not going to cover any aptitude. Only course we are going to cover.
Hello.
Tool access is for next. 15 days, sir, after the course completion in the online mode. If you are coming to the institute, you can use the tool till you get the job, right? But if you are working in the institute, but if you want to get the tool in the offline mode, sorry, online mode from the home, if you want to access, you will get the tool for entire course duration. Once advanced starts, then only we'll give the tool. In the basics, we're not going to give the tool because that tool is different. Once advanced starts, we'll give all the tools. Tool you can use for next 15 days until after the course completion. After course completion, you can use for next 15 days. Then if you want to use the tool, then you should come to the institute and you should use the tool. Yes, ask me the doubt what you were asking. Right? Student was asking something in the online. Please go ahead.
So how much analog part should we know for this course?
How much?
Analog part
Please.
we should know.
Analog part is not required, right? You need not to be knowing anything. Physical design is not dealing with analog.
Like,
It should totally be a digital design.
uh,
Analog design is separate.
okay, about that CMOS MOSFET, we should know
Nothing is
about that.
required, right? Because that course is done anyhow. We are going to do that course. If you enroll for basics, we are going to do that.
Okay, we'll do.
This is a
Okay, sir.
course, right? This we are going to do. You need not to know
Okay,
anything. Just you should
okay,
be knowing
okay.
some technical concepts like semiconductor. If I talk, what is meaning of semiconductor? That's some basic things you should be knowing. That's it.
Yeah, yeah,
What is conductor? What is semiconductor? Right? Even that also
yes,
we do. What is holes? What is electrons? Or what is N type? What is P type? Everything we do. You need not to be knowing anything. If you just join the course and if you attend the course properly and if you discuss with the mentor, right, that is
yeah,
sufficient. If you have any doubts, you should discuss with the mentor. At the last, if you
yeah.
tell that I
Okay.
didn't understand anything, means no one is going to take the responsibility of that. See, it is your responsibility
Yeah,
to
yeah,
discuss
yeah.
and get clarified when the course is going on.
Yeah, okay, sir. Thank you.
Thank you. Yes, sir. Then, if you don't have any other doubts, right? Okay, thank you, everyone. What will be the aptitude round, sir? Aptitude round. See, we are not going to conduct any test on aptitude. See, test is conducted on aptitude just to give the students uh, how what type of aptitude questions may be asked. See, every week on Sunday, 1 hour aptitude test is given. Just make you people understand what type of questions are asked in aptitude. But as of my knowledge, for VLSI Guru, for VLSI interviews, there is no written test with more aptitude. So there is no written test with aptitude only. Everything will be course content or digital. Only less questions will be with aptitude. Only like 5 questions or less than 5. That was happening. That is if you have written test. But 90% of companies will not take written test. They will directly go face to face. So written test is done only, for example, they have only 5 candidates and there are 100 candidates attending, then only they will take what? Written test. Or else they not take written test. They will directly go with, for example, if they are approaching VLSI Guru, if they are asking 5 candidates, we give only 5 candidates. We will not go, we give max to max 10 candidates. We are not going to give hundreds of candidates to them. So 90% you will not be having written test. So earlier Capgemini used to take written test. In the written test also, most of the questions was only on physical design. Only very less was from aptitude. Less means it hardly 2 to 3 questions from aptitude. And some product-based companies like MediaTek, all those companies will ask aptitude. Even that is very less. Most of the questions will be from physical design only, and there may be many questions from your digital if they are taking written test, right? So both are best. Analog layout versus PD. Analog layout has less admissions, right? You may get the job very easily. Analog layout, but analog layout, the benchmark. So what I can tell is your hike, right? You can go till 25 lakhs per annum. That is what the maximum you can reach in analog layout. But PD you can even work with 40 lakhs or 50 lakhs per annum, right? Because the higher level you can go with PD, but not with analog layout. That is what the difference is. But getting the job in analog layout is easy compared to VD because we have less candidates in analog layout. Why we have less candidates? Because they know that analog layout growing is very difficult later. Right? They know that. So that is what the thing. But both the course has same effect, and analog layout is easy compared to physical design. Analog layout you have to draw the layout, and that is easy compared to physical design. And if you are okay to have the salary till 25 lakhs, more than that, if I don't want, means you can join analog layout also. It is very good for I can tell like the ladies, because after some time they cannot focus, they cannot handle much pressure because of family things, right? Analog layout is also best part, right? Okay, then thank you everyone.